Hi students, welcome back to the class. So far we have learned about vectors, right? We learned about section formula. We now know the position vector of any point which divides a line segment joining two points internally as well as externally, right? And we done several problems using those formulas. Okay. In this section, we are going to solve exercise 10.3 of your NCERT textbook. Without any further intro, let's move on to it. The first question is, find the angle between two vectors A bar and B bar with the magnitude. The magnitude of vectors A bar and B bar is given by root 3 and 2 respectively. Having vector A dot vector B is equal to root 6. So, this is the question number 1. We have provided with mod A, mod B as well as A dot B. And we are asked to find angle between these two vectors. Whenever A dot B is given, always remember that to find the angle between those two vectors, it is enough to apply the dot product formula. We know that cos theta is equal to A dot B divided by mod A into mod B, right? It is equal to A dot B is nothing but root 6. Root 6 divided by mod A is root 3 and mod B is 2, which is root 3 into 2, right? Now, we can simplify it if necessary. Root 6 is nothing but root 3 into root 2. The simplification comes a necessity when you are trying to competitive exam, because in competitive exam the final answers are given in the simplified form. So we have to simplify it in order to get the accurate answer. Again, root 3 into 2, and we can cancel each other. The answer will be root 2 by 2. It is nothing but 1 by root 2. Because 2 can be written as root 2 into root 2, root 2 and root 2 cancels, and the final answer is 1 by root 2. So, this is the exercise question number 1. So, we shall move to the next question. Now, the question number 2 is that find the angle between the vectors. You are given with two vectors I cap minus 2j cap plus 3k cap, and the next vector is 3i cap minus 2j cap plus k cap. Always remember that whenever you are given with two vectors in the component form, you can find the angle between these two vectors simply by finding the dot product. You know that how to find the dot product when the component form is given. Just multiply and add the respective components, right? Now, we have A dot B is nothing but mod A mod B cos theta. This is our basic formula of dot product. From this formula we can find cos theta is nothing but vector A dot vector B divided by mod A into mod B, isn't it? Now A dot B is nothing but finding the sum of the product of the respective components, which is 1 into 3 is nothing but 3, minus 2 into minus 2 is nothing but plus 4, plus 3 into 1 is nothing but plus 3 again, divided by mod A is equal to, we can find modulus of A here. It is equal to square root over 1 square plus 2 square plus 3 square, right? It is equal to 1 plus 4 plus 9. It is equal to root 14. Now, mod B is equal to square root of 3 square plus 2 square plus 1 square, which is again root 14. So, we get root 14 into root 14, which is equal to 3 plus 4 plus 3 is nothing but 3 plus 4 7, 10 by 14. So, 10 by 14 can be again minimized as 5 by 7. So, cos theta is 5 by 7, hence theta is nothing but cos inverse of 5 by 7. So, the angle between these two vectors is nothing but cos inverse of 5 by 7. So, we can move to the next question. Now, the question number 3 is that find the projection of the vector I cap minus j cap. Find the projection of the vector I cap minus j cap on the vector I cap plus j cap. Let this be A bar and let this be B bar. So, we are given with two vectors A and B, and we have to find the projection of the vector A bar on B bar. We have learned that the projection of the vector A bar on B bar is nothing but A bar B cap, right? A bar B cap. So we can find it that way. A bar into the projection of the vector. Projection is equal to A bar into B cap. It is equal to A bar into, we have A bar as I cap minus J cap. I cap minus J cap dot B cap is nothing but I cap plus J cap divided by modulus of I cap plus J cap, right? It is equal to, we can find the dot product from here itself. 1 into 1, 1 plus minus 1 into 1, minus 1 divided by root of 1 plus 1 is 2. So 0 by root 2, which is equal to 0, which means that the projection of the vector A bar on the vector B bar is nothing but 0, which implies that these two vectors are perpendicular to each other. Since the dot product is 0, we have the result. Whenever two vectors have dot product equal to 0, those vectors will be perpendicular to each other, and this is very useful. This type of conclusions are very useful when it comes to competitive exams. So just remember those steps, and we have concluded that those two vectors are perpendicular to each other. Now we shall move to the next question. Now the fourth question is that find the projection of the vector I cap plus 3j cap plus 7k cap on the vector 7i cap minus j cap plus 8k cap. So we have to find the projection of this vector on this vector. As we know how to find it, the projection is nothing but A bar dot B cap. It is equal to I cap plus 3j cap plus 7k cap dot 7i cap minus j cap plus 8k cap divided by modulus of 7i cap minus j cap plus 8k cap, isn't it? Now we can directly find the dot product. It is equal to 1 into 7 is nothing but 7. 3 into minus 1 is nothing but minus 3. 7 into 8 is nothing but 56 plus 56 divided by root over 7 square plus 1 plus 8 square, isn't it? It is equal to it is equal to 7 minus 3 is nothing but 4. 4 plus 15 is 56 is nothing but 60 divided by root 114. So this is the projection of the vector A bar on the vector B bar. Now we shall move to the next question. So the exercise 5 of your textbook states that show that each of the given three vectors is a unit vector. Also show that they are mutually perpendicular to each other. So we have to show that each of these three vectors is a unit vector. See, observe that 2, 3, 6 are the coefficients here. Here also 2, 3, 6 are the coefficients. Here also 3, 2, 6. The coefficients in each of these three vectors are the same. So if you can show one of them is a unity vector, then obviously the rest of two are also unity vectors. So it is enough to show one of them is a unity vector and states that since all the coefficients are the same, they are also unity vectors. So let me show you how we can do that. We know that A bar is nothing but, we can take 1 by 7 inside the bracket so that it will become 2 by 7 I cap plus 3 by 7 j cap plus 6 by 7 k cap, right? Now we shall find the magnitude of the vector A bar. So mod A bar is nothing but square root over 2 by 7 the whole square plus 3 by 7 the whole square plus 6 by 7 the whole square, right? It is equal to square root over 2 square plus 3 square plus 6 square whole divided by 7 square. Since 7 square is the common denominator, it is equal to square root over 49 divided by 49 and it is equal to 1. Hence we can conclude that vector A is a unit vector. Similarly, we can show that vector B is a unit vector and vector C is also a unit vector. Now our next part of this question is that we have to show that these three vectors are mutually perpendicular, right? So in order to show that three vectors are mutually perpendicular, it is enough to show that A dot B is 0. Since we have to show that these three vectors are mutually perpendicular, which means that we have to find the dot product for each possible pair, so that A dot B, B dot C and A dot C have to be evaluated, and we have to say that all of the dot products are 0, and hence we can claim that these three vectors are mutually perpendicular. Now A dot B is nothing but 2 by 7. This is 1 by 2. We can take 1 by 7 inside, and hence we can find the dot product, or else we can take 1 by 7 all as a common from both these vectors and just find the dot product in each case. So we have 2 by 7 into 3 by 7, plus into minus is minus, minus 3 by 7 into 6 by 7, 3 by 7 into 6 by 7, plus into plus is again plus, plus 6 by 7 into 2 by 7 into 2 by 7. Now we can take what? 7 as common from all these terms, 1 by 7. So 2 into 3 is 6, minus 3, 6 into 3 is 18, plus 6 into 2 is 12, which is equal to 0. So we can say that A dot B is 0, hence A and B is mutually perpendicular. Similarly, we can show that B dot C is equal to 0 and A dot C equal to 0. Hence, we can conclude that these three vectors are nothing but a set of mutually perpendicular vectors. I hope you understood this exercise well. Hence, we can move to the next one. So, now we shall move to the question number 6 of your textbook. Find mod A and mod B. So, we are asked to find mod A and mod B, and we are given with two conditions. Say A plus B dot, these are vectors always, so don't forget to put that vector sign over this, minus B. A plus B dot A minus B equal to 8, as well as mod A is equal to 8 into mod B. So this is the given conditions. So we have to find what? Mod A and mod B. So I hope you understood the question well. So let us check how we can deal with this. Given that A plus B dot A minus B equal to 8, right? So directly from this we can expand this left hand side. A dot A, vector A dot A plus B dot A plus B dot A minus A dot B, A dot B plus, sorry, minus, plus into minus is minus, minus B dot B equal to 8. Now B dot A and A dot B are the same, so it cancels each other. So we have mod A square minus mod B square is equal to nothing but 8. Alright. Now we have the next condition, mod A is equal to 8 into mod B. So we can write 8 into mod B instead of mod A. So we get 8 into mod B whole square minus mod B square equal to 8. Alright. Now this will become 64 mod B square minus mod B square is equal to 8. Now we can take mod B square out and we can find mod B square. So we have mod B square equal to 64 minus 1 equal to 8. See, we took mod B square outside. So we have mod B square is nothing but 8 by 63. Right. So we have mod B is nothing but root 8 divided by root 63. It is equal to, we can make them more simple. 8 is nothing but 4 into 2. When taking outside the square root of 4, we got 2 root 2 divided by 63 is nothing but 9 into 7. So the square root of 9 is nothing but 3 root 7. So this is nothing but mod B. Now we have to find mod A. We have this equation, right? So we can substitute mod B in this equation to get mod A. So we have modulus of A is nothing but 8 into mod B. Mod B is 2 root 2 divided by 3 root 7. 2 root 2 divided by 3 root 7, right? Now we can multiply them to get 16 root 2 divided by 3 root 7. This will be the value of mod A. So this is a very simple example if you know how to multiply these two and apply this condition properly. So we can move to the next example. Next we can evaluate the product. The seventh question, evaluate the product 3a minus 5b dot 2a plus 7b. 2a plus 7b. So we have to evaluate this product. It is very easy if you know the properties of dot product. We can just open the bracket so that the answer will be 3a into dot 2a is nothing but 6a dot a. Now 3a into 7b, 3a dot 7b plus 3 into 7 is 21 a dot b, right? Minus 5b dot 2a is nothing but minus 10 b dot a. Minus 5b dot 7b is nothing but minus 35 b dot b. Now a dot a is nothing but mod a square, 6 mod a square. 21 a dot b and b dot a are the same, so 21 minus 10 is nothing but 11 plus 11 a dot b minus 35 mod b square. This is the simplest or this is the most appropriate form of this expansion. So our answer stop by this. So whenever you are asked in exam to evaluate this product, so just expand this and reach in an expression like this. Now we can move to the next question. So now we shall move to the question number 8 of your textbook. Find the magnitude of two vectors a and b having the same magnitude such that the angle between them is 60 degree and their scalar product is 1 by 2. So we have to find magnitude of two vectors mod a and mod b, and the given conditions are that mod a is equal to mod b and a dot b is equal to 1 by 2 and the angle between them is 60 degree, right? So we can find the angle between the magnitude of each vectors just by using the dot product formula. A dot b is equal to mod a into mod b cos theta. This was our formula, right? Now a dot b is given as 1 by 2. It is equal to mod a equal to mod b. So we can substitute mod a is equal to mod b, then it will become mod a square. Cos theta equal to 60 degree. So cos 60 degree. Now we know that cos 60 degree is nothing but 1 by 2. So we have 1 by 2 equal to mod a square. Cos 60 is equal to again 1 by 2. Now when we can isolate mod a square in the right hand side so that mod a square is equal to 1 and hence mod a is equal to 1 equal to mod b because mod a is equal to mod b. So we can find the magnitude of mod a and mod b as 1. So this is the example. Now we can move to the example question number 9 of your textbook. Now we shall move to the question number 9. Find mod x bar. So we are asked to find mod x bar and the given condition are if for a unit vector a. So a bar is nothing but a unit vector. If for a unit vector a, x bar minus a bar dot x bar plus a bar is equal to 12. So this is the given condition and we have to find mod x bar. As we know, we can directly open this bracket so that mod x bar minus a bar dot x bar plus x bar dot a bar minus a bar dot a bar, which is equal to 12, right? Now it will become mod x square minus a bar dot x bar and x bar dot a will be cancelled, hence it will become mod a square equal to 12. Now mod a square is equal to 1 since a is a unit vector, so we have mod x bar square is equal to 12. This is 1 and when it goes to the right hand side it will become plus 1. So mod x is equal to nothing but root of 13. So mod x is nothing but root 13. This will be the answer of the exercise. Now we shall move to the next question. So now we shall move to the question number 10. if a bar is equal to 2i cap plus 2j cap plus 3k cap, 2i cap plus 2j cap plus 3k cap, and b bar is equal to minus I cap plus 2j cap plus k cap, and c bar is equal to 3i cap plus j cap, then it is such that a bar plus lambda b is perpendicular to c bar. This is the given condition. Then we have to find the value of lambda. So we are given with the three vectors and we have to find the value of lambda, and the given condition is a bar plus lambda b is perpendicular to c bar. First of all, we have to find a bar plus lambda b bar. From this it is clear that this is equal to 2i cap plus 2j cap plus 3k cap. This is a bar plus lambda into b bar minus I cap plus 2j cap plus k cap, right? Now we can simplify this result. 2i cap minus lambda I, right? So 2 minus lambda I cap, 2i cap minus lambda I, this is lambda multiplied by minus I, so 2i minus lambda I, so we can take I cap outside, so we will get 2 minus lambda I cap plus 2j cap plus 2 lambda j cap, which is equal to 2 plus 2 lambda j cap, right, plus 3k cap plus lambda k cap, which is equal to 3 plus lambda k cap. Right, if you have any doubt regarding this, just calculate this separately such that 2i plus minus lambda I will be the first component, 2i minus lambda I. So we can take 2 minus lambda and I cap outside, so it will become 2 minus lambda into I cap. Similarly, we can obtain all other terms. So that's very simple. Now we got a plus lambda b, and given condition is that it is perpendicular to c bar. So we know that whenever two vectors are perpendicular, the dot product must be equal to 0. So c bar dot this must be equal to 0. So we have c bar is equal to 3i cap plus j cap plus 0k cap. We write this because we can avoid errors during calculation. So we get c bar and a bar plus lambda b bar. Now we can find, since the given condition is perpendicularity, we can use the property that whenever two vectors are perpendicular, its dot product will be always be equal to 0. So we can use that property. So we have a bar plus lambda b bar dot c bar equal to, we can find the dot product, 2 minus lambda into 3, the component wise product, plus 2 plus 2 lambda into 1. Here the coefficient of j cap is 1. So we have 2 plus 2 lambda into 1 plus 0 into this, 0 into any number equal to 0. So this will be 0. So this is the dot product, and this is equal to 0 just because these two vectors are perpendicular, and we know that whenever two vectors are perpendicular, its dot product will definitely be equal to 0. So we can simplify this result, this expression. 2 into 3 equal to 6 minus 3 lambda plus 2 plus 2 lambda is equal to 0. Now 6 plus 2 is nothing but 8. 8 minus 3 lambda plus 2 lambda is nothing but minus lambda equal to 0. So we get lambda is equal to nothing but 8. This is the answer of the question number 10 of your textbook. Now we shall move to the next question. So now we shall move to the question number 11. Show that mod a bar b bar plus mod b bar a bar perpendicular to mod a bar b bar minus mod b bar a bar. So we are asked to find a condition for, or the two vectors are perpendicular or not. We know that whenever two vectors are perpendicular, their dot product must be equal to 0. So we can directly find the dot product. So we have mod a bar b bar plus mod b bar a bar dot a bar mod a bar b bar minus mod b bar a bar, right? Now we can directly find the dot product. So we can find first component, mod a square, mod a into mod a is nothing but mod a square, b bar dot b bar, right? Now mod b bar mod a bar plus mod b bar mod A bar into A bar dot B bar, A bar dot P bar. This is the second component. Now we can multiply this with this. Plus into minus is nothing but minus mod A bar mod B bar, mod A bar mod B bar. Okay. Now B bar dot A bar, B bar dot A bar. Now we can multiply this into this. Plus into minus, minus, minus. Mod B bar into mod B bar is nothing but mod B bar square. Now A bar into A bar dot A bar. Now see, mod B bar dot B bar minus mod A bar B bar dot A bar. These two are the same number, so it cancels each other. So the next step contains mod A square. B bar dot B bar is nothing but again mod B square. These two cancels. Now minus mod B square, A bar dot A bar is nothing but mod A square. See, these two numbers are the same, hence the result will be 0. This is very simple example. Just find the dot product and prove that these two vectors result dot product will be 0. So we can definitely conclude that these two vectors are perpendicular to each other. Now we shall move to the next question. Now we shall discuss about question number 12. If A bar dot A bar is equal to 0 and if A bar dot A bar equal to 0 and A bar dot B bar is equal to 0, what can be concluded about vector B bar? This question means that whether B bar is a unit vector or a zero vector or any vector, or it can be any vector or not. This is the meaning of this question. We should say something about B bar. Since A bar dot A bar is equal to 0, definitely mod A square is equal to 0. Since A bar dot A bar is nothing but mod A square. Taking square root, we get mod A is equal to 0. Now, vector A dot vector B is nothing but mod A mod B cos theta. Right. Since mod A is equal to 0, this will be definitely 0. Whatever be the vector B bar. So, definitely B bar, vector B bar can be any vector. Whether it can be a zero vector or a unit vector or any vector, the answer A dot B will always be 0 since mod A is equal to 0. So that's the answer of this question. We shall move to the next question. Now the question number 13 of your textbook. If A, B, C are unit vectors, so A, B, C are unit vectors such that A plus B plus C is equal to 0, find the value of A dot B plus B dot C plus A dot C. This is the question. A, B, C are nothing but unit vectors. So we are given with three conditions. A, B, C are unit vectors. A plus B plus C is equal to 0 and the value of, we are asked to find the value of this A dot B plus B dot C plus C dot A. Clearly, we know that since A plus B plus C is equal to 0, the whole square will also be 0, right? So we can directly write A plus B plus C, the whole square is equal to 0. Right, now let's consider the left side. It is equal to A plus B plus C dot A plus B plus C, which is equal to 0 because this is equal to 0, right? Okay, now we know that A plus B plus C the whole square is equal to, in the case of arithmetic numbers, A square plus B square plus C square plus 2AB plus 2BC plus 2CA. This is also true in the case of vectors. We can apply that result here, or you can multiply each number, or you can find the product of each numbers, doesn't matter, or the answer will always be the same. So we can have A square plus B square plus C square plus 2A dot B plus 2B dot C plus 2A dot C is equal to 0. Now, A, B, C are unit vectors, so this always be 1. 1 plus 1 plus 1 plus 2 into A dot B plus B dot C plus A dot C is equal to 0. Now this is 3 and it can go to the right hand side, and so that it will be 2 into this quantity is equal to minus 1. So A dot B plus B dot C plus A dot C is nothing but minus 1 by 2. This was our required answer. So we can move to the next question. Always remember that here we used the identity a plus b plus c the whole square equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and this result is true in the case of real numbers. And dot product can also be called as scalar product, which means that the properties which is satisfied in the case of scalars can also be applied in the case of dot product, so that we can easily apply the result. Now we can move to the next question. Now we shall move to the question number 14. If either a equal to 0 or b equal to 0, then a dot b is equal to 0. But the converse need not be true. Justify your answer with an example. So in this question, first of all, given that if either a vector a equal to 0 or vector b is equal to 0, then it implies that a dot b is equal to 0, which is obvious. If a is equal to 0 or b is equal to 0, then mod a is equal to 0 or mod b is equal to 0. Namakariam, vector a dot vector b is nothing but mod a mod b cos theta. If either vector a is equal to 0 or b is equal to 0, then either mod a is equal to 0 or mod b equal to 0. Hence the product will become 0, so that a dot b is equal to 0. Now we have to prove that a dot b need not be 0. Sorry, if a dot b is equal to 0, then a and b is 0 ആകണം എന്ന് നിർബന്ധമില്ല എന്നാണ് കാണിക്കേണ്ടത്. For that we shall choose the vectors. Vector a is equal to 2i cap plus 4j cap plus 3k cap. This is just an example. You can choose any example like this. And vector b is equal to 3i cap plus 3j cap minus 6k cap. Now we shall show that a dot b is nothing but 0. How we can show that a dot b is equal to? A dot b is equal to, we know that whenever we are given two vectors in the component form, in order to find a dot b, just find the product of the respective components. So 2 into 3 is nothing but 6 plus 4 into 3 is nothing but 12. Now 6 into 3 is nothing but 18, but the sign is minus here, so minus 18, and the answer is 0. So a dot b is equal to 0. Now we shall find modulus of a, which is equal to square root of 2 square 4 plus 16 plus 9, which is not equal to 0 obviously. Now mod b, which is equal to square root of 3 square plus 3 square plus 6 square, it is also not equal to 0. So it is clear that for these two vectors a dot b is definitely equal to 0, but vector a not equal to 0 and vector b not equal to 0. That means that if a is equal to 0 or b equal to 0, then obviously a dot b is equal to 0. But if a dot b equal to 0, it does not imply that a vector a is equal to 0 or vector b is equal to 0. So that's the question number 14. Now we shall move to the question number 15 of your textbook. The question states that if the vertices a, b, c of a triangle ABC are 1, 2, 3, minus 1, 0, 0 and 0, 1, 2 respectively, then find angle ABC. We know that if we are given with 3 points like this, A, B, C, then angle ABC is nothing but the angle formed here, that is the angle between BA and BC. So first of all we have to find vector BA and vector BC. We know that whenever we are given with 2 points, we know the vector joining the 2-point formula. BA is nothing but 1 minus minus 1 I cap. 1 minus minus 1 I cap is nothing but 2 I cap. Now 2 minus 0 I cap is nothing but, sorry, j cap is nothing but 2 j cap plus 3 k cap. This is nothing but 2 I cap, because 1 plus 1 is equal to 2. So 2 I cap plus 2 j cap plus 3 k cap. Now BC is equal to 0 minus minus 1 is 1 I cap plus 1 minus 0 j cap, 1 j cap plus 2 minus 0 k cap. 2 minus 0 is nothing but 2 k cap. So we get BA and BC like this. Now we can find mod BA and mod BC, right? Mod BA is nothing but square root over 2 square is 4, 4 plus 4 plus 9. So that is 4 plus 4 is 18 plus 9 is nothing but 17. So root 17 will be mod BA. Now mod BC. 1 plus 1 is 2, 2 plus 4 is nothing but root 6. So we get mod BA and mod BC like this. Now we know that whenever we are able to find BA dot BC, it gives us mod BA dot into mod BC into cos theta, where theta is the angle between BA and BC. So we have to find this theta. So from here we have cos theta is nothing but BA dot BC divided by mod BA into mod BC, right? It is equal to, now BA dot BC, it is nothing but we have the component form, so it can be easily found by just multiplying the respective components. So we have BA dot BC is equal to 2 plus 2 plus 6, it is nothing but 10. So we have cos theta is nothing but 10 by root 17 into root 6. So we have theta is nothing but 10 cos inverse of 10 by root 17 into root 6. So this is the angle between the vectors BA and BC. So we can move to the next question. Now moving on to the question number 16. Show that the points 1, 2, 7, 2, 6, 3, 3, 10, minus 1 are collinear. This kind of problems has been done before in this chapter itself. So in order to find 3 points ABC, or in order to show 3 points ABC are collinear, we adopted the strategy that modulus of AB. Suppose that if we have 3 points A, B and C. 3 points are collinear. Collinear points means those points which lie on the same straight line. So whenever 3 points are collinear, the sum of the magnitude of two vectors AB, BC must be equal to the sum of the magnitude of the bigger vector. So always remember this fact. Whenever 3 points are collinear, whenever these 3 points are collinear, we have the distance between these two vectors, which is the magnitude of the vector BA or the vector AB, and the distance between these two vectors, which is the magnitude of the vector CB or the magnitude of the vector BC, must be equal to the magnitude of the bigger vector. I considered here it as AC. Maybe it can change to AB. ഇവരുടെ ഓർഡർ വേണം മാറാം. എയും ബിയും സിയും ഒക്കെ വേണമെങ്കിൽ ഇങ്ങനെയൊക്കെ ആകാം. അതായത് ബിഗ്ഗർ വെക്ടർ എ ബിയും സ്മോളർ വെക്ടേഴ്സ് എ സിയും സി ബിയും ഒക്കെ ആവാം. അതെങ്ങനെയാണ് നമ്മൾ ഐഡൻറ്റിഫൈ ചെയ്യുന്നത്? വി ജസ്റ്റ് ഫൈൻഡ് ദ മാഗ്നിറ്റ്യൂഡ് ഓഫ് എ ബി, ബി സി ആൻഡ് എ സി. ഇഫ് യു ക്യാൻ ഫൈൻഡ് ദാറ്റ് ദ സം ഓഫ് ടു മാഗ്നിറ്റ്യൂഡ്സ് ഈക്വൽ ടു ദ bigger magnitude, then we can definitely say that this happens, which means that the 3 points are collinear. I am giving you this work as a homework so that you can exercise this kind of question well. If you have any doubt, just comment here or ask me in person so we can clear it out. So we can move to the next question. Now we shall move to question number 17 of your textbook. Show that the vectors 2i cap minus j cap plus k cap, I cap minus 3j cap minus 5k cap, 3i cap minus 4j cap minus 4k cap be the position vectors of the points A, B, C respectively. Then we have to show that it forms the vertices of a right angled triangle. So we have given with 3 points A, B, C. We have to prove that this forms the vertices of a right angled triangle. We know that. How we can proceed? First of all, we have to find vectors AB, BC and AC respectively. Here we are given with 3 points. Actually 3 position vectors of the 3 points. We know how to find AB, BC and AC from those points. First of all, AB. Here terminal point is B and initial point is A. So 1 minus 2 equal to minus I cap, minus 3 minus minus 1. So it is minus 2 j cap, minus 5 minus 1, so minus 6 k cap. Now next BC. This is the C is the terminal point and B is the initial point. So 3 minus 1, 2 I cap, minus 4 minus minus 3 minus 4 plus 3, it is equal to minus j cap, minus 4 minus minus 5 minus 4 plus 5, which is equal to plus k cap. Now the next one AC, this is the terminus and this is the initial. Now 3 minus 2 I cap, so I cap, minus 4 minus minus j cap, minus 4 plus j cap, so minus 3 j cap, minus 4 minus k cap is nothing but minus 5 k cap. Now we can find modulus of the vector AB, modulus of the vector BC and modulus of the vector AC. This is equal to square root of 1 plus 4 plus 36, which is equal to 41. Now BC is nothing but square root of 4 plus 1 plus 1, which is equal to root 6, and AC is equal to nothing but square root of 25 plus 9 is nothing but 34 plus 1, so 36. Sorry, 25 plus 9, 34 plus 1, 35. So we get this. Now hence it is clear that we have BC square plus AC square equal to AB square, right? Because 35 plus 6 is nothing but 41. So these three vectors satisfies the Pythagoras theorem. This is the sides of the right angle triangle. Hence we can say that this is the sides of the right angle triangle as the sides satisfies the Pythagoras theorem. Now we shall directly move to the next question. Now we shall move to question number 18 of your textbook. If A is a non-zero vector of magnitude A and lambda is a non-zero scalar, then lambda A is a unit vector. If so, we are asked that if lambda A is a condition for lambda A to be a unit vector, and we are given with various options. Let us check it out. Lambda A is a unit vector only if the magnitude is equal to 1, right? That is mod lambda into mod A must be equal to 1. That is mod A must be equal to 1 by mod lambda. That is A must be equal to 1 by mod lambda. Since given that A is a non-zero vector of magnitude A, so mod A is nothing but small a. So we have small a is equal to nothing but 1 by mod lambda. So option D is correct. So I hope you understood all these questions very clearly. If you have any doubt, you can contact me and ask me. So stay tuned for the next video. In the next video, we will discuss about the cross product, which is one of the most important topic from this chapter. So stay tuned for that. Until then, bye bye.